Section 1.2, we're going to define and measure angles. So our objective is to copy and measure angles. So to do that, we need to know what an angle is. And to do that, we need to know what a ray is. Remember from the previous section that a ray has one endpoint and extends forever in one direction. And we always name a ray with 2 points with the end point coming first. So this would be ray FG. That symbol there always goes to the right. So that would be ray FG. So an angle is built from rays or segments. An angle is 2 segments, which by when we use the word segment, we mean line segments, 2 segments or rays that share a common endpoint, that share the same endpoint. Okay, so if I draw 2 rays, let's see, one ray like this, and I draw another ray with that same endpoint, let's say like this, I have created an angle. And let's call this ray BA. Put A over here, and we'll call this one BC. So my 2 rays are, the angle is formed by ray BA, ray symbol, and ray BC. Okay, denoting that they have the same endpoint. So when I'm referring to this angle, we use this thing called an angle symbol. It almost looks like a less than symbol. If you remember, our less than symbol looks like that. The angle symbol, the one line is more horizontal. And so I don't confuse this for that. Normally when I'm handwriting, I'll put a little arc measure through it to denote an angle. So I would refer to this angle as just its vertex B. I would call it angle B if that is the only angle with the vertex B. What I mean by that is I could have other rays coming also off of B, and I can't call them all angle B because I don't know which one I'm talking about. So if you name it with the vertex, it has to be the only angle at that vertex. Oh, we never talked about the word vertex yet. That's our next word, the vertex. The vertex is that point right there. Okay, so in words, it is the common endpoint of an angle. Okay, so the vertex is that common angle, that common endpoint of the angle. So since this is the endpoint of both rays, it's the one that they have in common. It's the vertex. Okay, so I can call it angle B by its vertex if it's the only angle at that vertex. If it's not the only angle at that vertex, another way we can name an angle, and this is probably the most common, is using 3 points, and I would call it angle ABC or angle CBA, but always that vertex is in the middle. Vertex is in the middle. Okay, so that vertex is in the middle. So I'd either call it CBA or ABC. The vertex is always in the middle. Now, one other way that other textbooks tend to, and then they tend to use a different color with this, but doesn't have to be, is they will put either little numbers, like let's say a number 1, inside the angle, and they would refer to it as angle 1. So sometimes we label it with little numbers inside. And then when we get into more advanced math, so later on in geometry, when we get into trig or in pre-calc, sometimes we also use Greek letters. The most common is the number theta, or alpha, kind of looks like that side fishy, or beta, which kind of is a weird B. Okay. Those are used in more advanced classes usually, but we will introduce them a bit later on. But they're also used. We're not going to use them much in this section. For the most part, we're just going to be using the points, okay, to name our angles. So all different ways of naming the angles. So it would be the same angle, whereas whether I call this angle B, angle ABC, or angle 1, it's all the same angle. It's just using different ways of naming them. I like to compare it to, here is me using the full name, first, middle, and last name. Okay, so me referring to my son as Henry Ronald Neal, first, middle, last name. Okay, whereas this would maybe just me calling him Henry, or even a nickname would be the shorthand. And that works if he's the only Henry in the room. But if there's multiple Henrys, I have to use the full name. Okay, if that makes sense. Okay, our last is adjacent angles. Adjacent by definition means side by side. The word adjacent means side by side. If you and your best friend rented adjacent apartments, your apartments would share a wall, or they would be like one right next to the other. So adjacent angles is really referring to two angles who are side by side. So two angles in the same plane, meaning I have to be able to draw them both on one sheet of paper. So they're in the same plane. If you remember from yesterday, that plane is that flat idea. So you can't have like one angle coming out of the paper and one being on the paper. Okay, with a common vertex. With a common vertex and side, but no common interior points. Okay, we're going to make sense of this here in a minute. Sorry if you can't read that. We can zoom in a little bit. It's two angles in the same plane with a common vertex and side, but no common interior points. Okay, so first of all, we didn't really specify a side of an angle. This is a vertex. This whole thing is what we refer to as the side. Angles have two sides. It's those two rays. So side, side, angle is that in the middle. Okay, and there's the vertex. Okay, so it's two angles in the same plane. So if I draw two angles, let's draw one angle like this, and let's call this angle M, N, we'll call this point P. Now I need to draw another angle that shares that side. So I'm going to draw an angle that shares this side, PN, and we'll have it go this way. Now let's put out here Q. So this angle, angle MNP, angle MNP, and angle PNQ are adjacent because they both share the side NP. See, there's NP and there's NP. NP is in both of them. Now this last bit, no common interior points. What that means is very commonly, and I'm going to do this in red to show how it's wrong, is if I look at angle MNP and angle MNQ. MNP, this little angle right here, and MNQ. They're in the same plane. They share a vertex. Both of their vertexes is N. And they also share a side. MN is in both of them. But points inside of angle MNP are also inside angle MNQ. They can't have no common interior points. So basically this bit is guaranteeing that they don't overlap. One angle can't be on top of the other one, like in this situation. So this, I'm going to come to X, those are not adjacent. They can't overlap. One can't be on top of the other for them to be adjacent. They have to strictly be just side by side. Okay. All right, so now we're going to go ahead and we're going to draw. We want to for the first bit here, we want to draw two rays that form an angle. Okay, I just need to draw two rays and have them share an endpoint. We should probably give these rays a name. I'm going to have them go like this. Okay. And I don't know, let's W, X, and Y. So there are my two rays, XW and XY, form an angle. Okay. Because they share an endpoint. Okay. Not hard. We want to draw two rays that do not form an angle. So I need to draw two rays. For them not to form an angle, they cannot share an endpoint. So I could draw one ray here. I don't know, FE. And then I could draw another one over here. ST. Okay. There's my two rays. They don't form an angle because they don't share an endpoint. The endpoint of this one is F. The endpoint of this one is S. No, and those aren't on top of each other. Okay. So we want to, that wasn't too bad. Now we want to draw and label adjacent angles ABC and CBD. And we want to write all possible ways to name all three angles using the point names. Okay, so I'm going to first start by drawing angle ABC. Okay, so here would be A, B, and C. Because remember, that vertex is always in the middle. So here that vertex is in the middle. And we want them to be adjacent, so I want them to share a side. So I look here, the vertex is also B, but the other point they have in common is C. And C is right here. So I'm going to have to go C, B, and come with D off of this direction somewhere. Okay, so we're going to put D here. So I have angle ABC and CBD. They are adjacent because they share this side, B to C, and B to C going that way, and B to C going this way. And then we want to write all possible ways to name all three angles. Okay, don't be confused. There are three angles here. Because we have so we have angle ABC. That's the one they gave us. We want to write all possible ways to name all three angles using the point names. So we have angle ABC. I could also switch it the other way around and call it angle CBA. I cannot call it angle B. There are too many angles here at angle B. So we have this little angle here written as ABC and CBA. That's really the only two ways I can write that one. The other one was CBD. Going CBD. So if we go the other way, DBC. Okay. So we want to write all possible ways to name all three angles. We've only named two angles. Here's one, here's two. There's also the big angle, the two included, ABD. There's that third angle, ABD. Or I could write it the other way around, DBA. I cannot just use angle B in this case, because if you notice, all of these are angle B. B is the vertex for all of them. I can't just use angle B. Okay. So now we want to draw and label angles ABC and angle DBE so they share the vertex B, but are not adjacent angles. Well, we just have to make sure that they're not side by side. So I'm going to go ahead and start with my angle ABC, the first one red there, ABC. And we want angle DBE. Notice B is the vertex, but D is not a point in this on this angle, and E is not a point. So as long as I have my vertex B, I can have that other angle anywhere I want, as long as it's not on either of these sides. So I'm going to go ahead, I'm going to put down here. And I don't know, let's go off this way. There are so many different ways of drawing this picture, you guys. This is just one of them. So we have D here and E here. So I have angle ABC, which is, and again, we're going to be using highlighters quite a bit. Let me grab mine. So we have angle ABC, which is right there. And then we also have angle DBE, which is right here. Do any of those sides overlap? Nope. For them to be adjacent, they have to not only share a vertex, but also a side, which these two do not.